Good morning. Uh,
Waalaikumsalam morning.
okay. So you have a good rest for almost 12 days almost 11 days that we didn't have class. And today we are going to continue again on the numbering system. We have a few slides there. Then after that, we go into logic gates. Hopefully, I'm not sure whether after logic gates I want to continue with the Boolean algebra or we stop there for today. And it depends. Let's see how it goes. I'm quite flexible on that. And we have about 2 hours, right? So I'm not sure whether it will be 2 hours or will be less. But what do you call it? I will make it not as boring as possible. So Nurin is why some of you basically just make sure that you are in. Then after that you leave and go and eat. Eh?
No it's puasa.
Puasa je.
So you go and sleep. Uh,
Sleep, sir, sleep.
sleep.
Potong
So
tidur.
uh, so now we have 10, 2, 4, 6, 8, 10, 10 students. It's okay. So now I'm going to any questions so far on the assignment? I think you submitted 2 assignments
Oh,
already,
sir.
right? Hmm?
Yes, sir.
So if you have any question and whatever you ask in through the WhatsApp or email, doesn't matter. I will try to answer. And now I'm going to share the slides. If you have no what do you call it, no question. What did I do? Okay. Now go into apps. Lecture. Oh, wait. Let me do this first. Logic. Okay. 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 Now the slideshow. Can you see the slides? Hexadecimal numbers.
Yes, sir.
Okay. Now we are going into the hexadecimal numbers. Actually, we have covered decimal numbers. We have covered binary, right? So now we
Yes,
are
sir.
going into the third one, which is hexadecimal numbers. And after that, we are going to cover the octal decimal numbers. That then basically we will finish the numbering systems. Then after that, we go into logic gates. So for hexadecimal numbers, the hexadecimal number system has 16 characters, which is the base 16. So what are those 16 characters? See that it composed of 16 numeric and alphanumeric characters. So the first numeric, 10 numeric, I think you know already, which is 1, which is start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
A,
And
B, C.
alpha numeric is A, B, C, D, and E. So most digital systems process binary data in groups that are multiple of 4 bits, making the hexadecimal very convenient because of each hexadecimal digits represent a 4-bit binary numbers. So each uh, character of hexadecimal represent by 4 bits. For example, let's say 0 in hexadecimal is actually 0000 in binary. If it's 1 in hexadecimal, it's actually 0001. Right down into 9. 9 is basically that in binary, is what? 1, 0, 0, 1. That is 9 in binary. Then A is 1, 0, 1, 0. Right down to F, which is 1, 1, 1, 1. So that is how you represent the hexadecimal numbers into 4 digits. So more specifically, 16 is actually equal to 2 to the power of 4. So it takes 4 digits to represent digits of binary to represent 1 digit of hexadecimal. So just like the example that I mentioned just now, from 0 to 15. Okay? So 10 numeric digits, which is 0 through 9, and 6 alphabetic characters, A through F, make up the hexadecimal number systems. So that is what the hexadecimal number is all about. So this is what I've mentioned just now, which is in decimal from 0 to 15, which is represented in 4-bit binary, 000, represent a 0h in hexadecimal. 1 is 0001, 1 in hexadecimal, right down to 9, which is 1001. So that is 9. 10 in hexadecimal is 1010 in binary. In hexadecimal, it represents as an A. 11, 1011 is B. 12, 1100 is C. 13, 1101 is D. 14 is 1110 is E. 15 is 1111 is F. So that is how you represent the decimal and binary in hexadecimal. Okay? Clear? So now, if you want to do conversion, for example, that you need to convert the binary to hexadecimal conversion. So let's say that you have 1100, 10, 100, 10, 10, 111. So we learned that every 4 bits of binary represents 1 digit of hexadecimal. So if we want to convert from binary to hexadecimal, therefore we need to group. We need to break up the binary numbers into group of 4 bits. So what you do is you start from the back, from the right. So you count 1, 2, 3, 4, one group. 1, 2, 3, 4, one group. 1, 2, 3, 4, one group. 1, 2, 3, 4 is one group. So in this case, for 1100100101010111, then you start from the back, from the right. So 1110 is one group. Then another group is 1010, another group. And another group is 0101 is another group. And 0011 is another group. So you start from here. So this is one group. This is one group. This is one group. And this is one group. And from there, you go to the table, the previous table. You go to here and you check. 011 is 7. 0101 is 5. 1010 is A. 1100 is a C. So therefore, the conversion of this number 1100101001010111 is actually CA57 in base 16 in hexadecimal. So you need to write this 16 down here as a base so we know. Okay? Clear? For the next one, B, we have a number 111111001011011001. Same thing as in the A. You start from the right, you count 4 bits. You group as one. The next 4 bits, another one. The next 4 bit is another one. The next 4 bit is another one. And you left with 2 bits. 2 bits, basically you add 2 zeros in front. You do that. You add 2 zeros in front. Right? So now you can convert. So this one is 0011 is 3. 1111 is F. 0001 is 1. 0110 is 6. 1001 is 9. So therefore, the answer is 3F169 base 16. In the hexadecimal. Any question on this, on the part B? Right?
No, sir.
No. So clear.
Dia
Okay.
tak akan terlebih macam ada 2 nombor lepas tu tak ada answer. Dia memang akan cukup 4 answer.
Yes. So for example, like this, okay, you have a balance of 2 right here, right? So you add and 2 zeros in front. So become 4 bit. So 3, right? So macam ni ada ni balance 2, right here. So you add 2 bits. But we don't show here lah. In this, but it's actually we add 2 bit here.
Yang table hexadecimal tu dia akan bagi ke ataupun kita kena hafal sir?
You have to remember. You have to hafal.
Okay sir.
Right? You have to hafal. We don't give. For this test, even actually for the normal closed book, closed notes, 2-hour test, we don't give you any formula. You have to remember.
So we have to remember all the number.
Yes. And especially take home open book, open notes, 24-hour test. We will not give you the formula, because you can find in the textbook or in notes and whatnot. The only thing that you cannot do is discuss with your friends. That's all. Right?
Oh, discuss.
Okay. The next one is how you convert from hexadecimal to binary. Just now we see how the binary convert to hexadecimal, and now the other way around. It's from hexadecimal convert to binary. So let's say you are given 3 hexadecimal numbers. Determine the binary numbers for the following hexadecimal numbers. A, 10A4 and base 16, because it's the hexadecimal. So how do you do this? So what you do is that each digits for hexadecimal, you write in terms of 4 bits of binary numbers. For example, this 1 is actually 0001. 0 is 0000. A is 1010. 4 is 0100. So therefore, the solution is 1000001010000, or 0001000010100101. Both answer acceptable. Okay. Whether you add in your answer, you add 3 zeros in front or you don't, both are acceptable. Right? For B, you have CF8E. So you're at CF8E. Then you expand and you write each digit, each hexadecimal digit in binary, in 4-bit binary. C is what? 1100. F is what? 1111. 8 is 1000. E is 1110. So the answer is 1100, 1111, 1000, 1110. Okay. So in terms of the Whether you start from the left or from the right, it does not matter when you do hexadecimal to binary conversion. For the binary to hexadecimal conversion, you start grouping from the right. You don't start from the left. You have to remember that. So there is a bit of difference, right? Whether you start from left or from the right. For binary to hexadecimal, you start from the right. For hexadecimal to binary, either way you can do. For C, 9742, then you expand into 4 bits. For each digit, you expand into 4 bits in binary. 9 is 1001, 7 is 0111, 4 is 0100, 2 is 0010. So the answer is 1001, 01111, 0100, 0010. Easy. Now, you want to convert into hexadecimal to decimal. There are 2 ways of doing this conversion. The long way is that you convert from hexadecimal to binary, then binary to to decimal. So you have 2 process. From hexadecimal to binary, which is you expand each digit into 4-bit representation. Then you use what we learned in the previous lecture, how to convert from binary to decimal. That is the first method. For example, convert the following hexadecimal numbers to decimal. Let's say 1C. So you write 1C, then 1 is 0001, C is 1100. You see this now? How that I say that you write in 4-bit here, compared with this one, this, you don't write. So actually both ways can, but I prefer this way. So from here, this is the conversion from hexa to binary. And here is the conversion from binary to decimal. So this is the second step. After you have convert to binary, then you multiply each, the ones that you have one with the weight. 0 multiplied by 2 to the power of 0, 0 multiplied by 2 to the power of 1, 1 multiplied by 2 to the power of 2, 1 multiplied by 2 to the power of 3, 1 multiplied by 2 to the power of 4, then this one is 0 because 0 times 2 to the power of 5 times 0 times 2 to the power of 6, 0 times 2 to the power of 7. So 0, so you get only this 4. So it's 16 plus 8 plus 4. So the answer is 28. So the conversion from 1C in hexadecimal to decimal is 28 in a base 10. So this is the reason why we write the base, because when you have this kind of question, which is in the conversion, if you don't write the base, we don't know whether 28 here is base 16 or base 10. So make sure in your exam, you write the base. If not, you will lose mark. Okay? When you do the conversion.
All right, sir.
For the second one, A85, base 16. So A85, so you expand. A is 1010, 8 is 1000, 5 is 0101. So now you expand, the next step, you convert binary to decimal. So 1 multiplied by 2 to the power of 0, 0 multiplied by 2 to the power of 1, 1 multiplied by 2 to the power of 2, then all these multiplied by the power, all multiplied by 0. This one is 1 multiplied by 2 to the power of 7. This one is 1 multiplied by 2 to the power of 9, and 1 multiplied by 2 to the power of 11. So 2 to the power of 11 is 2048. 2 to the power of 9 is 512. 2 to the power of 7 is 128. 2 to the power of 2 is 4. 2 to the power of 0 is 1. So you add all of them. So 2693 base 10. So that's how you do the hexadecimal to decimal conversion using this method, which is hexadecimal to binary first, then binary to decimal. So that is the first method. The second method is that you do a direct conversion from hexadecimal and direct to decimal. So this is the method. Another way is to multiply the decimal value of each hexadecimal digits by its weight and then take the sum of these products. For example, E5 base 16. So E5 base 16 is that 5 actually at the location of 16 to the power of 0, the first location. E is in the second location, which is 16 to the power of 1. So E multiplied by 16 to the power of 1 plus 5 multiplied by 16 to the power of 0. So E is 14. 14 times 16 plus 5 times 1. So the answer is 229 base 10. So that is a direct hexadecimal to decimal conversion. Second one, B2F8. B is in the fourth location, which is 16 to the power of 3. 2 is in the third location, which is the weight is 16 to the power of 2. F is actually in the second location is 16 to the power of 1. 8 is in the first location, 16 to the power of 0. B is 11. 16 to the power of 3 from here is 4096. 4096. So 11 multiplied by 4096. The second one is 2 times 256. The third one, F is 15 times 16 plus 8 times 1. So the answer is 45,816 in decimal. So either way, you can use. It depends on your preference. Okay, clear? So it's quite straightforward actually. So now we go into the last numbering system that we are going to cover in this course, which is octal numbers. The octal numbers is basically that is a base 8. So therefore, the symbol is actually from 0 to 7. So there is no digit 8 and 9 in octal. So if you look at this decimal number from 0 to 15, so and this is the representation in binary 00001. We have seen this, but you have not seen this in octal. So in octal representation, 0 is 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7. But when it comes to 8, then it becomes a 2 bits, a 2 digit, which is 1, 0. 9 is 1, 1, 10 is 1, 2, 13 is 1, 11 is 1, 3, right? 12 is 1, 4, 13 is 1, 5, 14 is 1, 6, 15 is 1, 7. We don't say 10, 11, 12, 13, 14, 15, 16, 17. But we say 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. When you are referring to octal numbers. Okay? So if you look at here, that 0 up to 7, this 3 digits, right? Then after that, this one, you repeat again, right? So octal numbers, actually, one digit of octal numbers can be represented by 3 bits in binary numbers. If it's hexadecimal just now, you represent in 4 bits, right? But in octal, you represent by 3 bits. You represent by 3 bits. Let's see how the conversion. Octal to decimal. This is from octal to decimal conversion. So this is a direct conversion. This is a direct conversion where you multiply by the weights of each position. For example, 2374 base 8. So you have to write base 8 because it can be hexadecimal, it can be decimal if you don't write the base here, 8. But when you write the base, then you know exactly 2374 represents in which numbering system. So in this case, 2374, 8, base 8 is in the octal numbering system. Therefore, you can convert 2 multiplied by 8 to the power of 3 plus 3 times 8 to the power of 2 plus 7 times 8 to the power of 1 plus 8 plus 4 times 8 to the power of 0. So 2 times 512, 3 times 64, 7 times 8, 4 times 1. So the answer is 1276 in decimal. So you have to write this. So, okay, wait. Can you use in the indirect method, which from octal, you convert to binary, then binary convert to decimal, just like in here, this method. Can you use for octal? Can or not? What's your opinion?
Cannot.
Why cannot? Let's try.
Boleh.
Let's try. Can you expand this 2374 to binary?
Can.
How?
Buat macam tadi. Divided by 4. 4
Are
part.
you sure divide by 4?
Oh, tak boleh sir.
Tak boleh sir, tak boleh sir.
Kena tukar kepada 10, lepas tu baru tukar kepada 2.
No,
Tukar kepada 5.
no.
Tak sir.
Main bantai je. Kan I dah cakap tadi. I dah bagi hint tadi. I dah bagi hint dah.
Terlepas.
Tidur lah ni.
Mana ada
Tidur
rasa
kan? Kan saya dah cakap.
mus tidur.
Tengok. You see here. Octal is base 8. Base 8 can be represented by 3. Can be represented by 3 bits.
Bits.
From 000, 001, 010, 011, 100, 101, 110, 111. 1. So each digit of octal number can be represented by 3 bits. Okay? Can be represented by 3 bits. So this number 2 is 0, 1, 0. Try to write 0, 1, 0. Right? Okay. 0, 1, 0. 3. What is 3? Is 0, 1, 1.
0, 1, 1.
7 is
Binary ya sir ni? Untuk binary ya sir?
yes. You
Oh.
convert to binary. So 7 is 1, 1, 1. 4 is 1, 0, 0.
0, 2, 2.
0, 2, 2 apa pula?
0, 0, 2, 2.
Mana
Mana ada tu?
kita dan
Ada lagi.
Sekejap sir.
Kau kat mana dia Sah?
0, 2, 2. 0, 2, 0, 0.
Mana ada tu?
Mana ada?
mana ada nombor 2, dia ada 0 dengan 1 je.
Saya cuba nak brain jap.
Binary. Binary is only zeros and one.
101 Zul. Itu.
1 0 1 1
101.
1 1 1
101 eh?
1 0 0.
Yeah, this one 2 is actually 0 1 0. 3 is 0 1 1. 7 is 1 1 1.
1.
4 is 1 0 0.
Zero. Betul lah tadi saya cakap.
Eh,
2.
kau
Cuma
cakap.
saya cakap ada zero je kat depan tu.
Oh,
So
kau kat mana?
now,
Tak apa.
now,
Take
Kau
5
cakap ada nombor 2.
The rest.
now, when you have the 2374, 2374, it becomes 0 1 0 0 1 1 1 1 1 1 0 0. Then you can convert that binary into decimal. So there is another way of doing it. That is indirect way. So actually you can use two methods to convert octal to decimal. By first, it's either directly octal to decimal or octal to binary, then binary to decimal. Just like how hexadecimal convert to decimal, which is hex convert to binary, binary convert to decimal. So you can use that. Try this as an exercise for you to do. 2374, convert to binary, then binary, convert to decimal. Do you get this number or not? 1276. You should get the same answer. The only difference between hexadecimal conversion to or octal conversion is that hexadecimal, each digit for hexadecimal you represent by 4 bits. Octal you represent by 3 bits. Simple. Now,
Sir, maknanya nanti dekat binary dia ada 16 digits lah sir.
untuk yang mana? Which one?
Yang sir cakap 2374 tu nanti dia akan
Yes.
ada 16 digit lah.
12.
3 plus 3 plus 3 plus 3. How many?
Oh,
3
12.
times 12. 3 times 4.
Oh, 16 tu bila sir?
16 tu
Ah,
hexa.
16 tadi.
Okey, terbalik.
Octal is 8.
Alright. Thank you.
When 8 is actually, you can represent 8 by 3 digits. So remember that. If it's 16, it's actually from 0 to 15, you can represent in 4 digits. So hex is 4 digit representation, octal is 3 representation. Okay. So this is when you want to convert decimal to octal conversion. A method of converting a decimal number to an octal number is repeated division by 8 method. The first remainder generated is the least significant digit, LSD. So for example, you want to convert 359 on base 10 to octal. So you take 359 divided by 8. So it's equal to 44.875. So the remainder is actually 0.875 times 8 is equal to 7. Then you take the quotient, 44, you divide by 8 again. So you get 5.5. So the remainder of 0.5, actually you multiply by 8, you get 4. And the quotient 5, you divide by 8, you get 0.625. So 0.625, so the remainder is 0.625 times 8, you get 5. And the quotient 0, basically you divide by 8 is still 0, so you stop. So the answer is 547 in base 8. So that's how you convert decimal to octal. Okay. Clear? Did we cover decimal to hexadecimal just now? Decimal to hexadecimal?
No.
No. we didn't cover, right? So, taking from this example, can we do that also for hexadecimal? You take decimal to hexadecimal conversion. What you need to do?
Darab sir.
No, division by 16.
Oh, divisions. Ah, yes,
Yeah.
16.
So the method is repeated division by 16 method. So you take this number, you divide by 16, you get a number, an answer. So the remainder you multiply by 16, that is the LSD. If you do that. So can you do this for hexadecimal as your exercise? So you have 2 exercise and you need to submit to me by tomorrow. As your
Apa sir?
Apa sih? Apa sih? Apa sih?
Ulang balik
Apa?
sir.
Ulang balik.
Saya test tadi.
There are 2 questions. This is your quiz. Carry marks.
Oh, pula.
Okay. Carry marks. This one,
Terus
Okay.
kelima.
2374. You use the method of you convert octal to decimal using the indirect conversion, which is octal to binary and binary to decimal. Using this example, 2374. So you use that method. Okay. The second quiz, the second question is you convert hexadecimal of 359 in hexadecimal. The 359 in decimal, convert into hexadecimal, into base 16.
Dah sir, saya dapat jawapan sir.
Nanti you submit.
Alah, kalkulator.
Share.
Tak, saya nak.
PM tepi, PM
Ada
tepi.
dua lah. 1, 2, 3, 7, 4.
Yes.
Yang tu daripada base 8 nak tukar kepada base binary.
Tukar kepada decimal, but using the method of octal to decimal, octal to binary, binary to decimal.
Okay.
Okay, so not this method, not based on this method, but alternative method which is not in the slide. I want you to do that. The method which is not in the slide.
Maknanya method yang macam tadi tu ke sir? Yang macam ada reminder tu ke sir?
This method. I want you
Okay,
to
okay,
use
okay,
this
okay.
method. Okay.
Alright.
For this question. For this, instead of decimal to octal, I want decimal to hexa.
Decimal to hexa.
Yes, 359. Using this method, but division by
359.
16 lah. Which is not in the slide. So I want you to try for this 359. So there are 2 questions, right? For you to submit by tomorrow through email. That is your quiz number 3.
2 question kan sir?
Yes, 2 questions.
Okay sir, biar saya ulang sir.
Okay.
2374 daripada octal tukar pada binary, lepas tu kepada decimal.
Yes.
And then 359 base 10 tukar kepada hexa.
Yes.
Okay, guna method yang ada
Division.
digit. Okay, division. Okay.
Division like this. Okay.
Right.
Now we have covered all the numbering systems that's relevant in digital. So this is actually octal to binary. Octal to binary I have mentioned just now earlier. To convert an octal to binary number, simply replace each octal digit with an appropriate 3 bits. So if it's hexadecimal, you replace by 4 bits. For octal, you replace by 3 bits. So let's say 13 in octal, then you replace by One is 001, 3 is 011. So 13 in octal is 001, 011 in binary. It's 7526 in octal. Then 7 is 111, 5 is 101, 2 is 010, 6 is 110. So therefore, the answer is 111, 101, 010, 110. So that's very straightforward, octal to binary conversion. Everybody can understand this, right? So very easy. Now we go into binary codes. This is another topic. How are you going to represent a number, a decimal number? And in binary codes, we have two common codes. One is called binary coded decimal, or BCD. Another method is we call it gray code. So there are two methods. So this is actually that you represent numbers in binary, and often used because of practical reasons. For example, if you use a binary code BCD, in BCD, you represent each decimal digit from 0 to 9 by a 4-bit binary code. Siapa punya call tu? Ini mesti tuan dia pergi tidur ni.
Alamak sir. Kantor je dah.
Siapa tu?
Tak tahu. Jerin.
Saya nak check boleh sebenarnya. I can go and I see siapa yang tak mute.
Ayu.
Siapa yang tak mute? So I tahulah.
Suzon sir puasa pergi tandas tu.
Pergi tidur.
Alam ni, pasang alam ni.
Suzon
Daripada tadi lagi tu. Ini tuan dia pergi somewhere else. Just active the video, just attend the meeting, but the body is not there.
Jerry je yang buka saya. Jerry je.
saya je yang buka je.
Siapa?
Jerry je. Azrin je.
Oh saya dah tahu dah sir.
Oh dah tahu dah.
Siapa?
Jerry.
Yang
So,
tahu je tahu.
Aku nampak siapa weh.
Yeah.
Dan
Memang.
kita senyap saja.
Saya boleh check.
Teruskan, sir.
Kalau saya nak check, saya boleh check. Aduh.
Dah tak ada dah bunyi.
Saya sebenarnya, saya boleh pergi kat sini. Saya boleh tengok.
Tu Arif dah bunyi je. Diam je.
Dia lah. Dia lah tu yang apa ni? Yang
Bukan. Tadi orang lain je.
Bukan sir.
Orang lain je.
Suzon sir.
buku ya ke?
Pergi toilet tu sir.
Hanya saya dengan Jerin je tahu sir.
So sekarang ni basically
Ya.
Arif Najmi baru mute dia punya tu.
Ayu.
Bukan sir. Kita orang tahu sir siapa.
Bukan sir.
Aku sambung cerita. Saya tunggu sesambung.
Sekejap sekejap. Saya punya ni. Okey. Nampak tak? Nampak slide? Binary codes.
Nampak sir.
Nampak Okay. Binary codes decimal, BCD. Binary coded decimal means that each decimal digit 0 through 9 is represented by binary codes of 4 bits. So 0 is represented by 0000, 1 is represented by 0001, 2 0010, 3 is 0011, 4 is 0100, 5 0101, 6 0110, 7 is 0111, 8 is 1000, 9 is 1001. So if a question says that the stream of binary bits in BCD, binary coded decimal, then you know how to convert that into decimal. Basically, you just take 4 bits at a time and convert into decimal. For example, convert each of the following decimal numbers to BCD. Let's say you have 35 in decimal. So if you want to convert into BCD, you just convert each digit into a 4-bit binary. 3, what? 0011. 5 is 0101. So therefore 35 is 0011, 0101. So you see that you have this leading zeros for 3. Instead of only 1 you present by 00. Remember, in the hexadecimal, I say that I like to add the 00 in front if it's what call it, less than 4 bit. So this is actually I like to what call it, to synchronize myself with the BCD. Each digit represented by 4 bits. Even for the hexadecimal, I like to add that leading zeros. Second example, if you have 2469 in binary, in decimal, and we want to convert into binary to represent that in BCD, so 2 is 0010, 4 is 0100, 6 is 0110, 9 is 1001. So this is actually in BCD. So the binary representation of a decimal number is different if we say that it's in the BCD format. In BCD format, you do this. You expand 2 into 4 bit, 4 in 4 bit, 6 in 4 bit, and 9 in 4 bit. If you remember, the conversion from decimal to binary is different. Remember, you take, if you want to convert a decimal to binary, that we divide by 2, by 2, by 2, by 2, right? Remember in the previous lecture?
Yes.
Yes.
Yeah.
So the answer will be different. So you have to be very careful when you read the question, whether the question wants it in the normal conversion of decimal to binary, or decimal to binary coded decimal, BCD. If it says BCD or binary coded decimal, you do this. You just expand to represent each digit by 4 bits. If it's decimal to binary conversion, then you have to divide by 2, by 2, by 2, by 2. Okay? So you have to be very careful in reading the question. Okay. This is binary coded decimal. Now, let's say the question says that convert each of the following BCD codes to decimal numbers. So when it says the BCD codes, therefore you take this binary stream of numbers and you group it into group of 4. So you start from the back, 010, 0110, 0001. So actually, if it says BCD, you can start from here also, because it's always represented by 4 bits. Right? It's always start each digit always represented by 4 bits. Okay, so it will write like this. If it has in BCD code, it's always 4 bit. So you can start from the left also. So either way, you can start from the right or from the left in grouping the bits. So for example, 10001110. So you take 4 bit, convert. Take 4 bit, convert. So this is actually 86 in decimal. So you see this? The method of conversion BCD to decimal is different than conversion of binary to decimal. This looks like binary because it's ones and zeros. But this is actually in BCD format, BCD codes. So if it says BCD codes to decimal number, therefore the conversion is this method. If it says binary to decimal numbers, then you multiply. This is actually multiplied by 2 to the power of 1, multiplied by 2 to the power of 3. This is multiplied by 2 to the power of 7. So you get a different answer. So in the test, sometimes that we give you one number like this, stream of binary, we say, that, okay, convert to, we say that maybe this is BCD, convert to decimal. So this is maybe binary, convert to decimal. We can do so many ways in asking question in the exam. So part B, 0011, 0101, 0001, convert to decimal. So we group into 4. 0011 is 3, 0101 is 5, 0001 is 1. So the answer is 351 in decimal. Another code, we call it gray code. The gray code is a bit tricky. It's unweighted and it's not an arithmetic code. That is, there are no specific weights assigned to the bits position. So it's not about mathematical calculation. No. For gray code, it's more about the changes from one bit to another bit. So it exhibits only a single bit change from one code word to the next in sequence. So it look at the stream of bits and which bit is changes, and you record that change. For example, let's say bit at location 0 is 0, bit at location 1 is also 0. Is there a change? There is no change. So you record that as no change. If, let's say, from the location of second location is 1, and the third location is 0, so there is a change. So you record that as a change. So gray code is actually recording those changes. Right? So this is also known as reflected binary code with the property that any two consecutive numbers differ only by 1 bit. So this is actually binary to gray code conversion. For example, the conversion of binary number 101110 to gray code is, okay, you start from the left. So 101110. This is the binary that you want to convert into gray code. So you start with the first one from the leftmost, 1. So the code is 1. After 1, the next one is 0. Is there a change? Yes, there is a change. Therefore, if there is a change, you record as 1. So the next bit is 1. So from 0 to the next bit, 1. Is there a change? Yes, there is a change from 0 to 1. So if there is a change, you record as 1. So from this 1 to the next bit, is there a change? 1 to 1. Is it a change? No, there is no change of bit. So you record as 0. And from 1 here to the next bit, is it a change? No.
Oh.
Then you record as 0. And 1 to the last bit. Is it a change? Yes. It's changed to 0. So you record as 1. So therefore, the gray code is 111001. That is the gray code for binary of 101110. So that is how you convert from binary to gray code.
So kalau depan tu kosong tu, kalau first tu
Kosong.
dia start
Then
dengan
you
zero.
start 0. Then you look at, is it a change or not? If it's a change, 1. If it's not a change,
1.
0.
Not
Okay.
0.
0.
So you move. Okay. So that is the gray code. This is the conversion from gray code to binary. Let's say you have a gray code of 110111. So this is a gray code now, and you want to convert to binary. So you start with 1 is actually indicate this, the first code here indicate whether it start from 0 or 1. If it's 0, you start from 0. If it's 1, you start from 1. So in this case, it's 1. So it start with a 1. So from 1 to 1, is it a change?
No, sir.
1 to 1. Are you sure? No, it's a change. Because this is to indicate the change. This indicate the change in the gray code.
Oh, yeah. Oh, 1 to 1. Yeah.
So this one indicate a change. So change from where?
Oh, 1
From
to
the
0.
first one is 1. So if there is a change, therefore,
0.
it means 0. And the next one, 0. Is it a change?
No, sir.
No. So if it's no change, you look at the previous one. What is is 0? So no
0,
change,
0.
then it's 0. Then the next location is 1. There is a change. So that means that from 0 change to 1.
1.
And 1, and the last one, there is also a change. So from 1 change to 0. So the answer is 1, 0, 0, 1, 0. So this is actually the binary number representing by this gray code 11011. Okay. In the test, you will have this kind of question to convert gray code, BCD, and whatnot. So clear?
Yes, sir.
Yes, sir.
Semua mengantuk, letih. Okay. So this is actually the gray code for binary. Let's say you have a decimal 0 and you convert into a binary 0000. So the gray code for 000 is 0000 because there is no change throughout. 1 represented in binary is 0001. So the gray code is 0, start from 0. The next one is 0. Is there a change? No. The next 0, is it a change? No. 1, is it a change from 0? Yes, it's 1. So for 2 is 0010. So you start from 0 here. Then the next one, is it a change from the first one? No, because it's 0, so 0. Then the next one, is it a change from 0 to 1? Yes, so 1. Then is it a change, the last one, from 1 to 0? Yes, so it's a change. So 2 in binary is 0010, and in gray code is 0011. So you all continue just like this. So this is actually the gray code representation for this decimal number and also for this binary number. So this is the gray code. So you can go through this on your own to get a further understanding of how this actually developed. So just now we see 2, 3 in binary is 0011. So this is basically that what do you call it? This in four-bit presentation. So in gray code, you start from 0. 0 to 0. Is it a change? No. So there is no change. From 0 to 1, is it a change? Yes. So it's 1. From 1 to 1, is it a change? No. Yeah. So 0, 0, 1, 0. So you take this last one. Say this one. Okay. 14. 14 is 1, 1, 1, 0. So you start from 1 because this is the starting. It's 1, so it's the 1 in gray code. So 1 to 1, is it a change? No. So it's 0. 1 to 1, is it a change? No. It's 0. 1 to 0, is it a change? Yes. So it's 1. So 14 in gray code is 1, 0, 0, 1. So that is the gray code. So we are done with the numbering systems. On numbering. If not, I'm going to stop this recording and I record another slide, another lecture for the logic gates. Okay. Okay. So, any questions so far? No.
Oh, sir.
No, sir.
No.
No.
So, so I will stop this recording and I will record another one on logic gates. Then after that, we can stop the lecture for today. Okay.
Yes, sir.
So
Alright,
I
sir.